Okay, so this is our first attempt at analysing anything using ANSYS. This is going to be an analysis of a plate with a hole. So here's the problem. We're going to be carrying out a 2D analysis of the plate with the hole. Here's the plate down the bottom here, and it's got a length of 40 millimeters, a height here of 20 millimeters. The hole in the middle here has got a diameter of 10 millimeters, and then at either end of the plate we apply a stress of 10 megapascals, placing the plate into tension. Right, so if we're going to analyse this using ANSYS, then the first thing we need to do is to open up ANSYS Workbench. Okay, so here's how we're going to start setting up the model for the analysis of the plate with a hole. So it's going to be a static structural analysis, so we just drag that into here and we create a standalone static structural analysis, and we will rename this plate with hole. Okay, so we can use the default engineering data, which if we double click on that we will see is our standard structural steel. So go back to the project. Now if we just click on geometry but don't double click it, don't open it, then we'll see down here that the analysis type is defined as 3D. We don't want that for this analysis, we want this to be a 2D analysis, so we go to the pull down and we select 2D. It's important to do that before we go any further. Once you've started creating the model, you can't then alter that. Right, so that's defined what type of analysis we have. We now need to start defining the geometry. So we go back up to here and we double click geometry, and that will open the design modeler. Okay, so here we are in Design Modeler, and we can start creating the geometry for our plate with a hole analysis. Before we start that, let's just check we're using the right units. So we've got to units and we're using millimeters, so that's okay. Because we're going to be creating a 2D analysis, we need to be working in the XY plane. So we click on the Z arm of the triad, and that reorientates us so we're looking directly at the XY plane. There are some useful additional tools which don't automatically appear in ANSYS for sketching. So if we go to Tools and Options, then we go to the sketching part of this little tree, and we'll see here that we can display a grid. So we've got Show Grid, that may or may not be set to yes. In yours needs to be set to yes, and at Snap to Grid, again make sure that is set to yes. And we can see further down here that the grid defaults in millimeters. It's 10 millimeters per, it is 1 millimeter is the minor grid spacing, and it's 10 millimeters for the major grid spacing, which should suit our analysis. Okay, we can now start setting up the sketch. So if we go into the sketching option, we can see our grid here. So let's start by creating the arc. We're using arc by center. So there's the center of the hole, and then 1, 2, 3, 4, 5 units to create a 10 millimeter diameter hole. Click that, come around and click that. Then the edges of that, so we've got line, and click that and that. Doesn't particularly matter how long it is, but we'll make it 20 millimeters long. So that's defined our geometry. It's a good idea to check that the dimensions that are correct. If we go to dimensions, and we can then dimension the hole, and we can see that the radius is 5 millimeters, and we can check the length. So click that, and the length is 20 millimeters, and the height, click that, and the height is 10 millimeters. So that's what we wanted. Okay, so that has defined that piece of geometry. So we'll go back into modeling, and we will see that on the XY plane we now have a sketch. Now we want to make that sketch into a body which can be analysed, but it's not an ordinary body, it needs to be a two-dimensional body. So if we go to concept and go to surfaces from sketches, then we can select that sketch, select apply, so it's now using that sketch, but we haven't got the right thickness yet. We want the thickness to be 2 millimeters, so change the thickness to 2 millimeters, and if we then generate, we will see that we now have a surface body which has got that profile and a thickness of 2 millimeters. So that's now defined our geometry, and it's automatically got the material attached, so we can now close Design Modeler. Okay, so we've now defined the geometry, so the next step is going to be to actually define the FEA model. So if we go to Model and double click there, it will open up Mechanical for us. Okay, so here we are in Mechanical, and I've skipped over the boring bit as it pulls the model in. Here's the plate with the hole in it. It's set up at the basic model. Again, the first thing I would do is to check what units we are using. So the units, and it's defaulted to meters. It will be much more sensible for us to use millimeters, kilograms, and newtons in this analysis. So I've got the right units selected now. The first thing I want to do is to make sure that I generate the mesh I want on here. I want a mesh of quadrilateral elements. So if we go to mesh, and if we right click on mesh in the tree, and we can insert a method. So in this method we can see that we haven't got any geometry selected at the moment, so click there and apply that geometry, and we will see that it's a quadrilateral dominant method, but down here we can see that we've got the free face mesh type as quadrilateral stroke triangle, and I want to change that so that it's all quadrilateral. It should be possible to mesh this using quadrilateral elements. Now that we've done that, we need to generate the mesh. So if we go up here to the mesh toolbar, then we can update the mesh. So that's updated the mesh, and then the next toolbar up we can then show the mesh. So that's the mesh of elements which we've created. Now they're all more or less the same size, and there are a few distorted elements around here. That could be improved. We could have more elements around this arc, and we could have fewer elements along this edge, but we'll stick with that for the moment for the purpose of this analysis. We now need to apply a load. So if we right click on static structural, then we can insert a load. So, and I'm going to define this as a pressure. So we're going to put a pressure on, and we need to define where we're applying it. So if I put a pressure on this edge here, and make that pressure negative. So select that edge, apply. So we've now got the edge, and I'm going to put a negative pressure on of -10, and it defaults to megapascals, which is sensible units to use here. So -10 megapascals applied to that edge. Right, so we've now got our basic analysis set up there. Let's see what happens if we try and solve that. So if we press solve, we'd have to wait a little bit for it to run through. So it's run through the analysis, and we can see down here there are a couple of warning messages. So let's have a look at the first one. First one says that the deformation is large compared to the multi-bounding box, and it's not sure whether or not we should have large deflections turned on. Okay, what's the second message say? The second warning message says that one of the more bodies is under constrained and it's undergoing rigid body motion, and ANSYS has automatically applied weak springs in order to give us a solution. Well, it's always dangerous to rely on ANSYS trying to fix problems for you, because it doesn't know what your intent is in carrying out this analysis. So these weak springs might not be doing the right thing. First thing I'd always do when looking at the results of the analysis are to look at the displacements. So if we go up to the solution, then we didn't define any solutions that we wanted to solution options, so we need to define one. So deformation is the first one. Let's look at the total deformation to start with. And we need to update those results. So there's the total deformation. It's sometimes easier if we have a look at an animation of that deformation. We can see a bit more clearly what's going on. So if we animate that, then what we see is that indeed the thing is moving essentially as a rigid body, and it is all displacing to the right. So there's obviously something not right there. Let's have a look and see what that does to the stresses. So again, we can go to solution and we go to stress, and we can look at, let's say we're looking at the normal stress in the X direction. So again, we have to update that result, and what we see here is the result of ANSYS applying these springs to try and prevent the rigid body motion. So it's put a spring on that corner, and that corner, and that has then generated stress raisers where they shouldn't really be stress raisers. So we've got a problem here which we need to solve, and the problem has been caused by rigid body motion. So this message here very clearly identified what the problem was: rigid body motion, because we haven't applied enough constraints to the problem. So we now need to apply some constraints. So if we go back to the structure, and we want a constraint on that edge in order to simulate the effect of symmetry and give us some resistance to the load which is applied on this edge. So go to supports, and we are going to apply a displacement constraint. So the displacement constraint is going to go on this edge. So apply that edge, and we want the displacements in the X direction to be 0 on that edge. So we type in 0, and that's going to put that constraint on there. Right, so that should have prevented the rigid body motion perhaps. Let's try solving it and see what happens. So solve the analysis, runs through again. Now this time we've managed to remove one of the warning messages, but we've still got this one that says that we might have rigid body motion, and it's still attached some weak springs. So it's a bit curious why it's done that, but let's have a look at what the deformation is. So the deformation, and no, that isn't right at all, because this thing is supposed to be not only symmetrical about that edge, but also symmetrical about this edge, and clearly isn't there. If we animate that, we see much more clearly what's happening there. So we're sliding down this edge, but we haven't got the constraint on this edge. So we need to do something about that. So let's go back to the model, and what we need to do is we need to apply a displacement constraint on this edge here to force the model to behave symmetrically about that edge. So it's easy enough to do. Supports, displacement, support, this time on that edge, apply that, and this time we want the displacement in the y direction to be 0. So enter that, and if we then rerun the analysis, let the analysis run through, and we will see that there are no warning messages now. If we look at the deformation, then that looks a lot more sensible, and if we animate that so we can see a bit more clearly what's happening, then we can see that we've got this constraint on there is working, and the constraint on that edge is working as well. And if we look at the stress, then the stress is what we would expect, and we're getting a high stress in the x direction at that point there due to the stress raising effect of the hole, and we can see the hole's elongated. So that has successfully analysed this plate with a central hole.